Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which checks if removing an edge can divide a binary tree into two halves. First, let us take an example. In the first example, if we remove edge 5, 6, the tree will be split into two trees of equal size. In the second example, it is not possible to do so. Now, let us see the algorithm which will assist us in this. Let us also have a sample tree to test our algorithm. We pass the root node to function check, so root will point to 5. Now, we have a variable n which stores the number of nodes in the given tree. We assume that the function to count the nodes in a tree is already there, and we return the count of the number of nodes to n. As there are 6 elements in this tree, n will be equal to 6. We take another variable res which we initially set to false. We call the check rec function with root, n and res passed as argument. As root is not null, we compute sizes of left and right children and store it in C. So we call for the left child of 5, which is 1, using a call stack. So as you can see, root now points to 1, and next we pass the left child of 1, which is 3. Again, as root is not pointing to null, we further pass the left child of 3, which is null. Hence, root points to null. As root is pointing to null, we return 0. Now, we pass the right child of 3, which is also null. Hence, root will again point to null. As root points to null, we again return 0. So, C will be equal to 1. Now we check if C is equal to n minus 1. As n minus 1 is equal to 5, so the if condition doesn't get satisfied and we return C, which is 1. Now we resume execution for node 1 and pass the right child of 1, which is null. So root again points to null. As root is pointing to null, we return 0. So C will be equal to 2, and as it is not equal to n minus 1, we return C and finish execution for node 1. Execution for root 5 is resumed, and now we pass the right child of 5, which is 6. Hence, root will point to 6. As root is not null, we call for the left and right children of 6. So, root will point to 7, which is the left child of 6. As root is not null, we pass the left child of 7, which is null. So this time root will point to null. As root is pointing to null, we return 0. Next, we pass the right child of 7, which is also null. Again, as root is pointing to null, we return 0. As C, which is equal to 1, not equal to n minus C, we return C. So 1 is returned and we finish execution for node 7. Next, we pass the right child of 6, which is 4. Hence, root will point to 4. As 4 is not null, we pass the left and right child of 4. As both of them are null, root will point to null. As root is pointing to null, we return 0. Now we pass the right child of 4, which is also null. Again, as root is pointing to null, we return 0. So C is equal to 1. We check if C is equal to n minus C. As it is false, we return 1 and finish execution for node 4. Now C becomes 3. This time C is equal to n minus C, and the if condition gets satisfied, so we set the res variable to true. Then we return c. So c becomes 6 now. C is not equal to n minus c and we return c. We finish execution of this program. So, it is possible to remove an edge and divide this binary tree into two halves. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.